Hi guys, so today we will be solving a hard type problem called trapping rainwater. This question has also been asked in Google interviews. So let's see what the question says. So the question says that we have non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. Okay, so as you can see that we have this elevation map, and the we can consider these black parts as buildings, and the blue part as the water that is blocked by these buildings on pouring it from above. Now we have been given an array which represents this elevation map. Now how we can say that is, so we have been sorry so we have been given an array 0 1 0 2 1 0 1 3 2 1 2 1, right? So 0 represents this box, 1 represents this one block, 0 represents again that there is no building, 2 represents 2 units of the building, and then 1 represents 1. Likewise we have 3, which represents here 3 blocks, 2 2 blocks, 1 1 block, 2 2 blocks. So let's try to find out where is the water blocked. So if we try to block the water here, it will be spilling it from here because there is no boundary to stop the spilling of water. But if we see at we see 2 3 4 5 6 7 8 9 10 11, so I index that array. Now if we see at second position, right, second position, there is 1 unit of blocked water. So if we see on its left side, we have 1 unit of the building, and on the right side we have 2 unit of the building, right? So that is why 1 block of water could be blocked here. Now for example, if we see in this example, so here there is 4 blocks of water has been blocked. Okay, so we have 1 here, 4, and here 1, and if we see, that is why the output is 6, right? So let's see where the indexes where the water is blocked. So the water is blocked here at second index, then next 3 4 5. So 1 block of water is also there at 4, at 5, and at 6, right? Next block of water is at 9th position. Okay, 9th index. So here 1 units of water has been trapped. So if we see on this where the water has been blocked, we have some height on the left and we have some height on the right. Here also if we see for 4, some height is there on its left and some height is also on the right, so long right here or here, right? So we have heights greater than that value. That is why we could be we could block that unit of water. Similarly for 0th, left and right they have some heights, that is why we could block. Here also if we see, we had, so the value was greater on left and the value was also greater on right, that is why we could block 1 unit of water. Now generally let's try to find the maximum height from the left end for any ith position, and likewise we will try to find the maximum height from the right for ith position. Now for this array, left would be, so if we see for 0th position is 0 because there is nothing on the left. Here also for first position there is nothing on the left. For this we have 1. For 2 units of building we have 1. For this we have 2. Then we have 2 for 5th position, so we have to number it also, or else we'll forget, right? So the maximum of for this one will also be 2. Now if we come here, which is the maximum between 3 and 2, then that will be 3 obviously. Then for this it would be 3, 7, 8. For this it would be 3 again, 3 again, and 3 again. So 9, 10, 11, right? Now let's try to find maximum height from the right end. So this would be reverse, so it would be 11. For 11, maximum height on the right is 1, obviously. It would be 1 because nothing is there. Then for 2, it will be 1 again. For this, it would be 2, 10, 9. Right? Now for 8, it would be 2. For 7, it would be 3. For 6th position, it would be 3. So 9, 8, 7, 6. Right, now for 5th position also it would be 3. 4, 3, 2, 1, 0. Okay, so 4th position it would be 3. 3rd position 3. 2nd position 3, 3 and 3. We'll try to reverse it. So it would be 3, 3, how much 3? 6, 3, 3, 3, 3, okay. 7 is also 3, 2, 2, 1, 1. Okay, so this is the right array. Now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, something got missed. 3. Okay, 9, 7, 9, 10, 11. Okay, so now we have to find a formula so that based on the heights we have to find the blocks of water that is that can be trapped here. Now for 0th position, if we see 0, so what is the minimum height between these two? 0, 3, it would be 0, and the height of that is 0, so no blocks of water can be trapped here, and likewise no blocks of water is trapped here. Now let's try to see for first position. So if we see 3, the right array has 3 and the left array has 0, so what is the minimum between 2? 0. And if we do 0 minus height of 1, so that is minus 1, so that will spill, right? So we can't trap any block of water here, so this would be, so negative 1 will not be allowed because it will spill from this. There is nothing right, nothing on the left. Now let's see for the second how we are getting one block of water trapped here. Okay, so we have 3 here, we have 1 here. What is the minimum between 2? 1. Now if we subtract this 0, so 1 minus 0 will be 1. So that is why 1 units of water is trapped here. Now let's try to see for this one, third. Left 1, right 3, minimum 1, 1 minus 2 minus 1. So it's again going to negative, so that is why we can't store water here. Now let's see for this fourth position. So for 4 we have 2 in the left, and in the right we have 3. Minimum is 3. 3 minus 1, it would be 2. So we can store 2 blocks of water. I think yes, 0, 1, 0, 2, 0, 1, 2, 3, 1, right? So 1 is there. What will be the... Okay, for 4 it is 2, 3. So minimum is 2. So 2 minus 1. So only 1 block of water. Yeah, sorry. So 2, minimum between 2 and 4 is 2. So 2 minus 1, 1. So we can store 1 block of water. Now let's see for this fifth position. So fifth position we have on the left we have 2, on the right we have 3. The minimum is 2, and 2 minus 0 is 2. So we can store here 2 blocks of water. So like this we have to add all the water blocks, and then we'll get this output. Now let's try to code this. Now how we can code this is, first let's try to create a left array that we created. So let's say we have current left equals to 0, and for I equals to 0 we'll run from 0 to height dot length I plus plus. Then we have to create an array, right? So let max left equals to empty, let max right equals to empty. Cool. So we'll push max left, we'll push into max left the current left. So this is for the first element 0, else current left would be math. So whatever would be the maximum between current left and height of I, that would be stored here, right? Now for right, for max right, getting the maximum height from the right, we will run a loop from height dot length minus 1, so in reverse. So what we can do is take a current right pointer, and then we'll run the loop from height dot length minus 1, I is greater than or equal to 0, I minus minus, and then we'll simply push the current right and then we will try to find whatever is in the maximum between current right and height of I. Right, now So we'll get the two arrays. So max right we have to reverse also because it is in reverse order for this. Okay, now we got both the maximum height from the left for every index and maximum height on the right for every index. Now we will run a loop from so now we will calculate blocks of water that is trapped. So we'll take a variable 0 and we'll try to apply the formula that we created. So that will be running from I equals to 0 to I is less than height dot length, right, and I plus plus. So the condition would be let result equals to math dot min, and that would be max left of the minimum between the ith element, then the element on in the max left array, meaning the maximum height on the left comma maximum height on the right minus the height of that particular element, right? Now we have to put a condition that if it is negative then we shouldn't push, so it should be greater than 0, and then we'll simply add the result and return the blocks of water that has been trapped. So let's see if the solution is correct or not. Okay, it works for the two test cases. Let's try to see for other test cases. Okay, works for all test cases now. So if you have more optimized solution for this question, so please comment down below, and thank you for watching this video.